So same questions today. So start with the first one of what's the background justification for the work, and does the review convince you of the importance of the area of study? So we'll ask for volunteers again this time, but maybe you're getting more confident with me to ask you for volunteers, and you will jump in quicker. Otherwise, I will have to hand select. So who would like to address this first question? All right. Yeah.
Yeah. The language quality they used, we can read once and we can understand. So I need to appreciate the author as a common person with a less information. If you read, we can understand better. I think so. This paper first.
So they did a good job of conveying the information in a clear way.
Yeah. Good. And coming to the first question, the background and justification for this work, it is well justified, and they have given extensive literature review, and they have clearly stated at the end of the introduction, the hypothesis is also clearly stated. What is that they want to do, and what is the thing that they want to test, and what is that they want to compare. It is clearly stated.
Good, good. Do you think that the gap was very clearly stated or more implied as to why the work needs to be done?
I will say that the gap is not that much clear, but they coming out with a new thing. They want to compare whatever they are coming out with a new thing with the existing thing.
Yeah.
But in the existing thing, it has already efficiency and compared to what is they are coming up.
Okay. Yeah, I think as you mentioned at the outset, the style of the writing is very clear and very concise in this particular article. And so when you get to the point of making a hypothesis or a purpose statement, if you've done a good job of the writing, it should be clear why you're doing this. Sometimes we still will instruct students to go ahead and just explicitly state that this is the hole that we will fill with our data, even though it seems to be clear by how you wrote it. So it's kind of an art form, I think, in this case. Good. Any other thoughts about the introduction as far as any of these questions and how they got to the hypothesis statements? If there's anything specifically, I'm looking for something here about the section right after their hypothesis statement. They continue to talk through the rest of that paragraph, right? So any ideas about why they continue to lay out other ideas that they're going to talk about besides just the hypothesis? You see which section I'm talking about? The very last paragraph of the introduction. So that maybe another group can chime in on this as to why they think they're doing this extra work above and beyond the hypothesis. Thanks. Yeah.
The purpose of the study was clearly stated, and it was clearly mentioned that we need to, for example, they have even mentioned that the previous high scorer had done this time for a 2-hour marathon race, and if we need to top that, if we need to achieve that, then what is the improvement that we need in the shoe, and how that we can achieve that improvement by this shoe, the particular shoe, and how energy cost saving can be achieved. So I think that is clearly stated, and that is, I think, sufficient enough, the purpose and the application of the study.
Yeah, that's an interesting approach in this article. And this, the last two questions here are kind of, it could be a research study, hypothesis-driven study, or it could be a design or methods development paper, right? So it may not require hypothesis. In this case, they almost do both. So they have a hypothesis statement, so they have a clearly testable goal that they're going to make with the hypothesis, but they also then state that here's some application goals that we hope to meet also. So that's almost more like a milestone or a development achievement to say we will also demonstrate why this is practical, not just leave it as here's a good scientific finding and leave it for the reader to interpret how you could apply it. So most of the time, people don't do this actually in the introduction section. They will just go ahead and do it in the discussion section without telling you ahead of time that we plan to talk about practical applications. So that's an interesting approach that they've taken in this case. Okay. All right, so let's move on to the methods. Same thing, give 5 minutes for discussion and then report back. right, this is your 1 minute warning. All right, are you ready to discuss? Yes, good answer. So the one extra thing I would add to this question list as a bit of a surprise to you is in our discussion today, in addition to answering what are relatively yes or no questions, today I'd like for you to also think about was there anything of controversy in the methods or something that you think is not really a good approach or that you would question whether that's a valid approach? Or the other side of that question, is there anything particularly about the methods that you kind of are surprised by and are impressed by? They might say, this is an amazing new method I've never heard of before. It's really exciting and I can't wait to try it in my own lab. So these are like opposite ends of the spectrum, right? One thing that you think is really questionable, maybe not the best approach, or one thing you think this is a really great approach, I'd like to use this. So keep that in mind as we get into the discussion about the methods. All right, so who would like to tackle the response about the methods? Maybe this side of the room. Two. Can I get to it? Here. Are you ready? Yeah.
So it's answer for the third question. So it seems it's meant for a broad scientific audience because it's readable compared to the last paper, which we couldn't understand from it. All technical words are there. But this is like it's for broad category of people.
Yes.
So that way third question is yes.
Okay. Yeah. There's a very distinct difference, right, between this paper and the previous one.
Maybe that's why it took long time yesterday because it was not readable. So many technical terms, so many equations. So here there is nothing like methodology is given here. It's just comparison. That's what they say. They apply the formula and compare it.
Right.
So which one is best one? Just want to ask. Giving a novel methodology or just comparing already existing systems?
I don't know if there's a best. I think it's specific to what is your purpose, what is the question, and also who's the audience. So if your purpose is to demonstrate you have a very different approach, then you need to really show the rigor of it, right? But that makes it less readable to everyone else. But if you want to show that there really is just a fair comparison between these three conditions and what's the possible application of that, then I think you don't need to restate the precise approach of every single methodological detail. Say we use this approach, we use this approach, we use this tool, we measured it, and it came out like this. So it's a little bit who's the audience, and also that this is not developing new technique or new science. It's just using existing techniques in science to test one thing. So it's a relatively simple paper as far as writing goes, but relatively difficult to do all the work, as you see in their description of their methods. Whereas maybe the other group, the difficulty of the work is to derive all those approaches and rigorously test it, but the actual kind of getting of the data is maybe the easy part. So, yeah, good. All right, we had a comment up here as well. We can either hand the microphone up or carry it.
First question, they have actually explained why they need to go for this in the introduction as well as in the materials and method. So why the approach is required and what is the formulation for this. And for the approach wise, they have clearly explained what is the material they have chosen how they have done the testing for the mechanical and the subject wise and the protocol also, like how each time, each visit, what is happening with the subject and how they are getting exposed or how the trial is being done. So the approach wise is clearly explained what is done in a proper manner.
Okay. So far, we're fairly happy with this paper, right? But someone else has their hand up. Yeah.
And the approach is quite clear, and they have explained why they have chosen certain tests. Just like they didn't say we have done a method, they have told like to imitate something. Also, the approach is quite clear, and they have used a shoe which already had set the world record also. So it seems to us like what is the contribution of the shoe towards the marathon winning, or how much the shoe is enhancing the person running capacity, or how much it adds to the running capacity of the runner. So that's how they have explained. And because of certain things, and so much force is applied on the shoe, it is enhancing the running capacity. So that is how they have explained it. And yeah, it is addressed to quite broad scientific group as it is very understandable.
Yeah. Good. All right. Yes. That's good.
So as everyone have discussed, it's very clear. All the approaches they have described is very clear. But concerning after the experimental protocol, they have explained each visit actually what they have performed in every visit, and the analysis is good. Yeah, we have to consider and interpret in every visit what exactly we understood, what we performed. But is it really required to explain every visit in detail in methods? It's just a clarification.
That's a good question. Yeah, in that respect, they almost go into too much detail. You might say. Do we really need to know every single minute of the subject's time? Sometimes that will come about because of the reviewer's request. That the reviewer might say, it looks like you have them there for several days, but it's not clear what you did each day. And I'm not clear if you did all of this on day one, or if you did this on day one, or this on day three. Also, the reviewer is likely to have some suspicion that the person will get fatigued if they do everything that's described in the methods. And so they may have requested the authors to be more explicit about when things happen, so there's not a question of fatigue on any of the metrics. So sometimes the work grows based on the response to the reviewer's comments, and so it becomes a rather unwieldy bit of writing at that point. But to their credit, they still do a good job of smoothly describing them. Yeah, good, thanks. Yeah, comment. Thanks for helping with the microphone.
So while I agree that all the methods were very well discussed, but here like they say that this custom testing was done in one dimension, and the actual thing that will be in 3 dimensions will be different. I think that it will be vastly different. So I'm not pretty sure how reliable this whole result will be.
Yeah.
Because there should be a considerable amount of difference with not only the round reaction force, but also other parameters, also the shear and everything. So that will also hold quite a lot of impact. Also, they said that one is a snug fit, one is some other kind of fit. So even if it will make quite a bit of difference in that.
Yeah, it's a good point to raise. I think the mechanical testing is just one-dimensional, but obviously we don't run like that. And that particular test gives them the answer about just the foam compliance, which is only one component of what's happening inside the shoe, right? So they have a very controlled test there, which is good. But as you mentioned, there's other things going on in the shoe. And as you see in the one image, the stack of the shoe has the carbon fiber plate in there as well that's shaped to what they think the rollover of the foot should be. But they don't really have a way to test that in this particular setup. So what they're relying on is that Nike did some tests on those carbon fiber plates and thought it was good enough to do some purpose for the shoe. But as the authors are writing this, they don't have access to that particular data or don't want to talk about it perhaps more specifically because it's fairly proprietary things that they're doing with these new shoes. So sometimes, yeah, this brings up a good point I think that we should discuss is this particular paper has some very clear conflicts of interest, right? Like two of the authors work for Nike, and everyone that's in the Colorado Boulder lab, that lab is often funded by Nike as well. And then one of the authors is a consultant with Nike, right? I think given all that, they do a good job of making it clear where those distinctions are, and it doesn't seem to be written as a way of like some sort of propaganda for the company. But you also have to wonder, why are they not talking about these other things? What are they holding back that might be proprietary? So, there's one comment here.
One thing that I would like to add on is that they have only male volunteers, male subjects. They don't have female subjects. So any particular reason for just male subjects? Like, yeah, we are going for shoes, marathon shoes, but I don't think so that will be male.
Yeah, that's a very good point.
Yeah.
So this becomes a very hot topic in the U.S. right now because historically, human subject research has really been predominantly male subjects, and then we know that 50% of the population is women, and so it's not really very appropriate or generalizable. So there's a lot of effort in even the funding models in the U.S. that the grant will require you to have statements about how will you balance your research subject recruitment to make sure you actually have equal data so you can really comment on the impact of both.
That we can generalize the treatment for both the genders equally.
Exactly, yes. Again, they don't say this in the paper, but I do know that the way Nike often does their testing is size 10 men's shoes, and then if they find something with that, then they do a bigger test with other sizes and both sexes as well. But this bigger paper, yeah, they don't actually justify or talk about why it's only males. So it's a good point for sure. And just comment here, yeah.
Just I want to have some clarification, sir. This is to match the weight for 3 pairs of shoes. Some standard thing they have it. To that they add weight like 47 grams and 51 grams. Whether adding a weight to a thing, can't it alter the performance?
So that's actually why they did it, because they have shown in the past, this group and others, that for every 100 grams of extra mass in the shoe, there's a 1% increase in the relative cost of transporting. So they didn't want the fact that the shoes had different mass points to throw off the way that the runners experience that and how much metabolic cost they have. So whether that's the best solution or to account for it some other way is arguable, but that was their solution to that. Yeah, good.
So according to me, why they given this more detail in materials and say, this session is, so as they are directly comparing with Adidas, they are given each and every step in a detailed manner, so that the competitor can evaluate how they are checked, how they are comparing. So that's the reason why they have given all the sessions in detail.
Right. Yeah, I think so. Yeah, but sometimes it gets a little bit hard to understand exactly why. So some of it they've explained well, and some they left a little bit unstated. But yeah, it's good. It's good discussion. Wow. So the methods were exciting for you today. This is good. I love it. Oh, there's even more. Good.
I think this paper is basically focused on geeks who like the materials, carbon fiber, and like that. But it is not focused on nerds who like mathematics and. Basically, it is a geeky paper and not a nerdy paper.
Okay, good. That's a good designation. I hadn't thought about that before. Yes. So you'll notice the title of the journal article, or the journal itself, is Sports Medicine, right? So we try to be a little careful on making too many quick judgments about the quality of the science or the quality of the readership based on the title of the journal. But you can very quickly say something that's in an IEEE journal, you expect engineers will be writing it and engineers will be reading it, right? Because there's a lot of E's in that title, and you think one of them must be engineer. But if you see sport, right away, people tend to downgrade the quality that they expect and also the quality of the readership, which is maybe fair, maybe not. And this particular group does, I would say, repeatedly good science, but also the way they write about things, they know it's a broader audience. So right away, some of the details and the technicalities they might skip over or not covered as well, or write about it in like broad strokes to make sure that if an athletic trainer or a sports med physician who hasn't ever taken an engineering course in their life can read it and understand what's going on. But because of that, it tends to be, do you love sports? You should do research. Read this paper instead of, do you want to solve math problems? Do you want to have some really cool designs in your lab that only you and your friends will know anything about? Then do engineering. So there's some generalizations that are made often in how these articles get written. So that's part of our effort in biomechanics, is to cross those two groups as often as possible so that they don't have these prejudged perceptions about each other's work, and also to improve the ability to read each other's work and understand what's going on. That's a good comment. Yeah.
Professor, I want to know as a reviewer point of view, like the subjects were having multiple visits and they were given a certain diets and all. So how much bias will you think like they'll be telling them too early, like they forgot it or not? What will be like a reviewer, your point of view?
Yeah, you would look for that as a reviewer, I think, to understand whether the subjects have some bias going into it, or even some preconceived notion about why they're there for the test. And having done some work with Nike as well, it often comes across that you are testing the next big cool shoe that's going to hit the market, and runners love that stuff. And so they may run differently for you, or they may eat the day before differently because they know they're being tested that day. And so the rest of the time they could be eating lots of fried food and too much soda and everything. Probably not, because these are really elite runners. But the day before the study, they may only eat vegetables and water, right? Just to be ready for a good performance that day. So that does bias data collections for sure. The difficult thing to do as a reviewer is to judge whether they've accounted for it or not. And I feel like they did a good job of accounting for that and trying to control for it. So, yeah. So I'm going to cut short the methods discussion. This was great. It's really exciting, but sometimes the time continues, even though we've sped up our discussion. So one more, yes.
Sir, I think that using lead pellets for that is they mentioned that they're adding some 51 and 47 grams of lead pellets,
Right.
which might relatively increase the weight up to 100 grams, I think. Why don't they use, instead of this, why don't they use carbon fiber, which may reasonably increase the weight as well as give a comfortable feeling to the runner?
So that's a good question. I think, so one of the shoes already has carbon fiber within it, their new prototype. So adding extra carbon fiber to the others, it's a little difficult, honestly, because they have to basically remake the shoe. Whereas lead pellets, you can just make small holes and embed them and have a very quick impact. What they don't tell us is where they put the lead pellets, I guess. So that could affect a little bit how the shoe performs. But I think that's the reasoning, is that for a very small units of lead, you can get a high rise in the mass. Whereas if you take the shoe apart and have to remake it to put in carbon fiber or something, that alters the condition, right? Good. All right, so I want to draw your attention to just two quick things. These are not as exciting as what we've been talking about, but I think they're important to note, both as a reader and a writer, and potentially a reviewer for work like this. If you look at section 2.2, the last paragraph before the human subjects, it describes this wording. So the mechanical testing revealed that the NP was approximately twofold more compliant than the NS and the AB shoes, and continues to go on and describe these things, right? This is within the methods section. And to me, these read as results. So this is something you want to be careful about, because I understand somewhat why they wrote it here, because it's kind of like the preamble to the results, because you have to set your condition. You have to say what the temperature was outside, or what the number of people were, what their sizes were, and things. In this case, they also say what the overall shoe response was, to then talk about what happened in the results for the human testing. But I think it should have been actually written into the results section as a primary finding. So that's a small thing that happens sometimes, where people will write about things in the wrong spot within the paper. So that's a small negative critique, but worth noting, I think. And then the other is right before 2.4, the experimental protocol. There's a statement, this is right underneath figure 3. There's a statement about the ethics approval. So they talk about how they've done things in accordance with the ethical standards, and they even cite the institutional review board and the application number. This is very thorough. Most people don't do that level of depiction of their human subjects review, but some journals are starting to require that you actually put the application and the reference number that's local to your university. And a lot of times as a reviewer or as an editor, that's one of just the easy check boxes that is clicked when you're reviewing something, is they have a great description of what they did with the humans, but we have no idea if they had approval for it. So maybe they did a good job, but maybe they abused the subjects. I mean, probably not, but since human subjects research requires some level of oversight, it's important to at least state that you had informed consent and that you had a review process for this. So just keep that in mind anytime, especially if you're jumping from simulations or developments and then eventually do a human test with the new device, you still need some form of approval for that. So make sure you get it and make sure you write about it. So that otherwise people may question, did you just test this out on yourself and you thought it was good and you walked on it just the right way? Is that really what happened? So some level of oversight is important to see. Okay, so methods was fun. Let's move to the results for this paper. So 5 more minutes of discussion about the results. right, just one more minute of discussion. All right, we're ready to discuss the results. Yes. All right. Who would like to start off with answering any of these questions?
So concerning the first questions, yes, they have described the primary findings in the text actually clearly. But concerning the figure, whatever they have explained in the text, they have explained in the figure caption also. So I know that has to be done on the.
Yeah, that's often discouraged actually. Usually because there's a page limit, and so you have the luxury of all that space to write about it once and then write about it again with the figure caption. Maybe they had an unlimited supply of pages from the journal, but usually you try to write as concise as possible. And so the figure caption becomes very short, or the text doesn't have much description. It's all in the figure.
And there's no table actually in this paper.
It's further towards in the discussion section. They put it.
And the statistical test are done here. They have done significant statistical research to support their findings.
They presented quite a lot, right, about the statistics. Yeah. There's always an argument about whether it's the appropriate statistics. But I would like to comment on that just a little bit because as a reader of these works, you can always compare what they're doing compared to what you know from the coursework or what you know from your own efforts in statistics. And usually there's always a difference of opinion, but it's just opinion for the most part. Sometimes people would like to really fight about statistical methods, but I often think that the findings should speak for themselves, and the stats is just kind of a mathematical proof that we've shown is not likely to be wrong. That's really it in the end. But most journals do require you, of course, to have some sort of statistical test. The readers and the reviewers might have a strong opinion about what you should do. And what I recommend as a writer is follow the reviewer says, I don't like the way you did that stats, do it like this instead. If you wish to get it published, you should do what they say, even if you disagree, honestly. If you disagree strongly, then you can come back and say, here's the reason why this statistical model is perfect and why I don't wish to do what you ask. But you want to be very diplomatic about that. Otherwise, it's just best to follow their instruction, and that'll be a quick way to get it published. Because in the end, in my opinion, any statistical test that is relatively capturing the hypothesis is good to do. And then there's nuance about what the actual p-value will be and what the assumptions that are met within the model, if those are accurate or appropriate or not. There's always a debate about that. I would say most of the time that's not the important part. The important part is all the science the person has done. Yes.
So regarding the first question, I have a different opinion. I don't think the primary findings are described clearly in the text because they have mentioned they have mentioned the analytic cost, but that is dependent on compliance and resilience, which they have clearly mentioned in the introduction part. So the mechanical testing part would be the primary finding, I think, and for that they haven't even mentioned, they haven't even shown any table. So that I think is incomplete, and that would be the primary finding, and then they haven't described it, and they don't even have it in the results.
So I think they do actually a little bit. So two points. So one is that I think if you look at the paragraph that we were describing in the methods that I think inappropriately gives some results, that gives some of the findings of their compression test. And also figure 3 is what they're showing as their primary result from the compression test. And it's really just a low displacement curve showing energy absorption and return efficiencies. So I think that that's what they're probably leaving their compression test at, is just at that point. They could provide a lot more, but yeah. So small disagreement. And the other clarification is, we talk about primary findings. That's kind of a hard word to apply. So sometimes it's the first thing that they've done, and maybe the most foundational thing is the compression test, for sure. So you can't understand everything else unless you've done that, right? But you might argue that their primary outcome that they really want you to know about is metabolic cost savings with the shoe, which then they spend a lot more time talking about, right? So kind of what's primary finding versus secondary finding is a little bit hard to say. The way I try to narrow it down is if it matches the hypothesis statement or the purpose statement, then that should be their primary outcome. And sometimes they have 2 or 3. So, yeah. But yeah, I mean, these questions, at first you look at them and say, it's a yes or it's a no, right? But it turns out it's more of a, well, maybe. And so then it's understanding kind of what was good about it and what was lacking about it. Yeah, it's good. Other thoughts on the results? Yes.
So I would like to address the last question. Are the findings qualified by statistical testing? Yes.
Mm-hmm.
I mean, they've used ANOVA, and I think it is also appropriate to really test the hypothesis. But is it appropriate to mention it in the methodology part and not mentioning it in the results part? I mean, because they haven't mentioned it in the results, but we have to look behind in the statistics.
Yeah, so sometimes this comes down to style. So people in their writing style, they will talk about their results in a narrative form, and then in just parentheses put p equal less than 0.01 or something like this. And then sometimes in a data table, they will have a lot more detail about which assumptions were met and whether it was truly significant or borderline significant. So they'll have more information there. But oftentimes you won't see the writer describe it in a specific reference to the test done. It won't say the ANOVA results showed that this is the number. They'll just say it was significant, p-value equal this. And so that assumes that they are reporting on the statistical test that they mentioned in the methods. But sometimes they leave that clear connection out. It's a fair critique for sure. Okay, anything else about the method or the results stand out to you or make you grumpy? So earlier we were talking a little bit about whether there's any sort of bias in the approach and in the methods part. I would also say there's a risk of bias in the results and how they're describing it, because one of their very first statements is there was a substantial difference of 4% between these things. It turns out if you find out when this was published and also when Nike was putting out this shoe and when they were building up for the effort to try to beat the 2-hour marathon mark, that's all they talked about was the 4%. They broadcast all over the place about this is the 4% savings shoe. It's going to make everyone faster by this amount if they're an elite runner that this shoe was specifically made for, which is Eliud Kipchoge, who tried to break the 2-hour mark and currently is the world record holder. So they designed the shoe specifically for him, and they came up with a way to test to see if it was really giving the results that they wanted. And in the end, 4% became the thing that was talked about all the time. So I think it's good. The research shows that 4% change is what happened. But after a while, you think, do you really need to talk about it in a way that's kind of advertisement? So you just want to be careful. Specifically, if you do industry partnership work, that in the end, you're the scientist who's not advertising for the company. It's very careful. It's very easy to kind of slip over that line because you tend to get excited about the data too and say, wow, we had 4% savings. That's amazing. I'll talk about it a lot. It turns out the company's been telling you it should be about 4%, we think. And then you find out, hey, it's 4%. And they're also paying your lab. So sometimes the conflict of interest is stated, and other times it's just like a mission creep a little bit. You tend to end up working for the company without realizing you are. So you just want to be careful. Okay, we'll move on to the discussion then. 5 more minutes. The discussions are more excited. Let's take more. Yes. Yeah. That helps. Maybe the topic. Yes. Yeah. Maybe the topic is a little bit easier to for everybody to understand. Okay, 1 more minute. let's go ahead and get started on the discussion here. So who would like to address any and all of these questions? Discussions are somewhat more fun than results sometimes to discuss, sometimes not. Yes. Let's see, where is the...
Yeah, they have mentioned the hypothesis again, and quite actually they have mentioned the 4% part a lot than they should have. The another interesting thing that I found was the hill strike that they found it only after the results and discussion part, and they haven't mentioned about hill strike like midfoot hill strike and rearfoot hill strike. They haven't mentioned about it at all in the introduction or methods part. So it seems as though they had no clue about it, and later on, while seeing the results, maybe they got a hold of that thing.
Yeah, that's an interesting observation. I think this paper, maybe more than most, has a fair amount of extra material in the discussion that wasn't really in the proposed, introduction or methods. This is probably a good thing to avoid most of the time. This particular group has kind of a reputation of being able to get away with it, partly because it's usually good writing and it's usually good information. It's just relatively bad form for strict research. But they do a good job of basically saying, here's our primary findings. Also, we thought of these other things and we want to tell you about them. Part of the reason they do that, I think, is that they want to still tell the story about why these data are impacting the idea of being able to break the record, or why they may actually be useful for an endurance runner. And the truth is, their study design may not have answered all of those things. So they continue to just talk about, and this, and also this, and also this other interesting thing that we want you to think about. So they kind of get away with it. It's probably bad practice. If you develop the ability to do it, then you can always sneak a little bit of extra information in there, which may be helpful to get the science progressed a little bit further. Mostly, I think it's just because they have a cool idea and they want to talk about it.
Sir, I wanted to ask two things actually. So while adding the lead pellets, they need to be placed very symmetrically, right? Otherwise, there might be a foot wobble and everything. So they haven't talked about that at all.
Right. We don't know. We don't know where the pellets are.
Okay.
Yeah.
And when they say that, suggests that unweighted NP shoes would quickly sink an average 4.4%, that is pretty weak. Don't you think? I mean, they don't really have a proof about that.
True. I think they're speculating on that if they basically take out those lead pellets again, that they would have an extra fraction of a percent of improvement. It's speculation, but it's somewhat grounded in most of the other studies that they've done and others have done about the 100 grams equals 1% metabolic cost. It's been a fairly repeatable finding for most studies. So I think that's where that speculation comes from. And some of it is they're shooting still towards the target of, we want to encourage this athlete to break 2 hours in the marathon, and they want to make the case that it's possible. So they start talking about, and even more, because these pellets back out, this may be able to do it, 4.4% then. And so they don't really have the data to show for that, but they're making an argument that that could be the case. So, yeah, it's maybe not again best practice, but yeah.
In this paper, according to you, should they have mentioned the placement of the lead pellets?
Yes, I think so. I think that would be something as a reviewer I would probably want to see more information about. Is give us more detail about where these lead pellets are. Are they in the heel itself? Are they in the forefoot of the shoe? Are they in the outsole? Are they taped to the top of the shoelaces? Like, where are these things? And I think that would affect how the footwear responds during the inertial state. Yeah. Yes.
So, don't you think that using lead is not a good option because lead poisoning will happen. Lead is toxic.
Right. Well, that's kind of a nice thing to avoid, right? But it's also a very nice bit of mass in a small volume. So I think this is why they still use it. I don't think that they let them go away with these shoes and let the lead end up somewhere dangerous. I think that they gather the lead back, but they don't say that, right? So I'm left to infer or imply that they might be taking the shoes back, sacrificing them, and taking the lead back out, putting it back in a jar for next time. Yeah, but it might be worth pursuing if you want to replace mass. Then maybe there's some other component that you can use that isn't quite so toxic.
So, they have mentioned that the complaint mechanisms they have used still more improve the energetics in the kinematics biomechanical point of view. This is a positive approach they are giving to other researchers to, yeah, we can still improve this from 4 to some more kind of a thing. Are they, are they encouraging other researchers in this point of view because they haven't done that kinematics point of
Right.
they have mentioned that,
Yeah,
but still it can improve the energetics more, they are saying.
yeah, that's part of the thing that this group gets away with is they speculate a little bit and then they also encourage the community to answer the rest of the questions. Sometimes that's the hinting that they're going to answer the questions in the next paper. Other times it's saying, well, we've done our job. Everyone else should do this other part. But I think it's a fair claim that this is something that should be explored further, and that there will be findings that will come from it. You can take the question about why they didn't support it in what they have, but do they not have the data for that? Do they decide not to instrument that way? And it's likely it becomes too cumbersome to put everything on the human wall there in the test. But it could be a reviewer question as well as why they should do that first. So in response, they couldn't get, well, we didn't have the space or the time to do that, but we'll talk about it. Anytime you see something that stands out within the writing that kind of doesn't match the pattern of how they write, it's usually because they responded to a reviewer to add some extra material. All right, so I think for the sake of time, we will jump really quickly through the next 3 bits. Not even to discuss necessarily, but maybe show of hands. So generally, would you say this is a good quality manuscript? Vote yes or hold your vote. Good quality manuscript, hands up. Okay, good. Bad quality manuscript, hands up. All right, you are very nice people. No, I agree. This is a good quality manuscript. It has some flaws that we've talked about, but it's almost like you can forgive the authors that they got excited about things and that the journal would be excited, that the reviewers can call them back. So that happens sometimes, but it's not the cleanest, purest bit of research out there. How about topic? Yes? No? Mostly yes? According to them, right? It has, this person's going to break the 2-hour mark now if they have these shoes. It's kind of what you take home from the paper. So that's all right. This is something you can probably keep to yourself. How about as a reviewer or as an editor? As it is right now, would you accept it and say yes? It's a no. Good. I like it. How many for yes? Okay. How about for no? It's an interesting discovery. It's good. So the only yes vote that I was able to visually see is from a faculty student. So this is interesting. It's actually, this happens a lot in our journal club. The students start to get a little bit like a sense that they're a shark and there's blood in the water, because they start getting about. And at the end of it, they say, I can do better work than this, and it's not so good. Because what have we done? We just revealed all the cracks, right? We just showed all the flaws. Then we're reviewing and editing and having to make these decisions about what's acceptable to go in and not for their own work as well as the students' work, as well as the things they're reviewing. And so they're interestingly a little bit more tolerant of the flaws because everyone has flaws. We still accept you. We still accept the paper, even with flaws. So that's kind of interesting. The students get excited, tear it apart, and the eyes in the room say, it's okay, don't get so angry. It's so it's interesting. Okay, so then just the last point is, for you to consider response, but just keep in mind, like, well, how does this compare to the other paper we described or discussed, and how is it similar? I think it's pretty clear from our discussion where the differences are, but they're also, you are likely to find that across all of the areas, there's still a pattern. There's still the intro method results discussion. Some engineering journals, you'll probably find that doesn't actually follow. Deepak and I have written a few, doesn't follow that pattern at all. It's more like, here are the number of things we're going to do in the script. Keep going. It's not an obvious intro method results. It's more of a, I don't know how you describe it, like a way. Anyway, this is pretty common though. All right, so we're running out of time, but I won't even bring up the other slides because they're really the same. And now it's not responding. But so if you can bring up in your sheets there the clinical paper, if you have it with you. It had to do with the total knee arthroplasty. We're going to jump quickly to that paper for just 10 minutes. Talk about things, and you want to have tea. So we'll just shift gears real quickly. And this sport biomechanics took up so much time this morning that we'll have just a brief moment to talk about the clinical paper. Does everyone have it? Yes? No? It should be in the same packet just towards the end. So maybe we'll do something slightly different with this one instead of having group discussion time, because as you can see, actually this is a really good point to talk about. So how long did it take us to talk about that one paper? We started at 10, we just finished, hour and 15 minutes. So you can see that to do this well, it takes time, but also you want to be mindful if you're the one guiding the discussion to watch the clock, because if you're in class and you're doing this, it will take the entire hour of your class, like we're doing here, or maybe even more. And part of that is because this is maybe new to you, and we're talking about things quite a bit more than we might otherwise. But if the topic is exciting to people, then you want to let them discuss it. You don't want to say, sorry, time's up, can't talk about that anymore. Right? But sometimes as a teacher, you have to do that, right? You have to cut them off and move on. But if you're doing a journal club, just with time to really get a good discussion going, which is something we struggle with in the US because we think everything can happen in 1 hour chunks. And so we schedule a journal club from 10 to 11. And people have an appointment at 11, it's across campus, they leave at 11:45, and so we have 45 minutes to discuss, and then we actually don't get through half the paper because we got excited about the methods. And so you want to be realistic basically about that. Maybe you take the journal club in 2 sessions. So today, methods, next week, results discussion, something like that. Okay, so what we'll do for just a real brief moment, with the total knee arthroplasty paper, just what would you see different? Maybe we'll ask just these final questions here. What are the similarities between the clinical biomechanics paper and these other 2? Is there anything that's in common or similar between the 3? Almost like give an opinion about this. Like, yeah, I think this thing is similar between those. Anybody? I think she has. All right, I'll do a bit of a survey then. So, did they justify their work in the introduction? Yes? Some say no? All right, good. Sometimes the clinical papers, they actually get too quickly to the hypothesis, and they don't actually justify what's good in view of literature. That's a common problem, actually. Their hypothesis. I believe yes. From when I read it again this morning. Can you agree with that? Is there a hypothesis statement? Maybe not. I don't think there's a. There is? Or no? No. Okay. But there's a purpose statement, right? And it's a fairly thorough purpose statement. So best practice for sure is to have a purpose statement followed by a hypothesis statement. And probably even better is to follow the hypothesis statement with, we will show this is yes or it's no by having a finding that is increased in this variable. That's really the cleanest way to write this section. So if you have a very thorough purpose statement, it becomes kind of clear what you're going to test, probably. But it's still better to include hypothesis. All right, are the methods clear? Are they described thoroughly? What do you think overall? After having just talked about the sport biomechanics one, right, where they went kind of too thoroughly, too far down that road, this is a little bit different than that, right? But given what you have read so far in the other two papers, would you say these methods are thorough? Yes? Thorough enough? I think this one has more page constraints because they write a bit more concisely. Yeah. Are the methods detailed enough that you think you could probably replicate the study? Or at least get close to it? If you have the luxury of having access to a lot of patients who are getting total knee replacements, then maybe, yeah, right? Okay. How about statistics? Do they have statistics listed out? Yes? Yes. Good. All right. Results. Are the results clearly stated in the text? What do you think? Clearly stated results? Hands up for yes. We have 1, 2. Hands up for no, not clearly stated results. Hands up for I'm still reading the results and trying to figure out. Okay, good. Honest responses. Yeah. This, similar to the last paper, has some interesting approaches to present the data. Very common in clinical related papers to have most of the findings in tables. I don't know why exactly. I think it's possibly due to the fact that part of their readership is going to be clinicians, and they want clinicians to be able to basically have a lookup table that says 40-year-old female, these conditions, walks at this speed. The answer of joint moment is 12. Okay, got it. I should expect 12. You know, they look for these things as like quick find lookup tables. But then you also notice that there's some interesting figures. So which one is it? Figure 2. So actually, I was planning to just show this up on the board real quick. So I think you have a black and white copy, is that right? So it's kind of hard to see what's actually going on there. right, so up on the screen we have figure 2 in color. And so with this, I think it's important to just quiz you a little bit. Do you remember those curves I was showing you the other day? Do these look familiar? Good. Pattern recognition. I like it. But they're very thick, right? There's a lot going on inside these curves. They especially can't see it in black and white, which is a challenge. So often we will actually encourage people to make their figures in black and white before they submit them to the journal, so that if they're ever printed in black and white, it's still interpretable what you have. Otherwise, you're relying on people to have a tablet or a viewer or to print it in color. And most of the readers don't really have that, right? So maybe you can expect tablets for people to be able to do it, but maybe not. So with knee kinematics, the thing to point out is you see these gray sections here on each of the curves. It's a little bit hard to see on the screen, but there's like gray bands on each of these. That's normative data from a separate sample of 25 people that they had collected that were age matched, that they basically said these are healthy, unaffected humans walking that are at the same age. So they have basically a plus or minus standard deviation band that they show as a comparative norm. So that's important to look at when you look at clinical gait analysis studies, is do they have a normative data point or not? So with that, you'll notice that both sets of patient groups, pre and post-surgery, never rise to quite the same amount of deflection in early stance as the normative group. And then during swing, they also don't quite rise into that band. But you will see that the swing has increased post-surgery, which is these two red and black lines here, compared to pre-surgery here. So that's a small finding. The varus valgus angle should be right around 0 on average for normative data. Pre and post-surgery, they are more varus, meaning that the foot or the shank is actually more medial to the femur. So they're doing what we call in the US bow-legged, right? So this is probably predisposing them to have medial compartment loading that's excessive, to have that alignment, which then leads to the knee varus valgus moment finding where this is the normative data here in gray. Pre-surgery is up here. Post-surgery is reduced, but not quite back to normative. So this, if you remember right, we were talking about this peak and this overall value the other day about having excessive loading on the medial compartment. This varus valgus moment is something that clinicians often will try to reduce the load on that medial compartment of the knee. But you could argue that it's really hard to do that if you still have a varus alignment. So they've solved part of it, perhaps, but maybe not quite all of it with just pure geometry of the joint itself. And then this is just a comment on, this is a similar pattern basically to the textbook that I showed you the other day. This is, if you see this pattern, you know that your kinematic kinetic calculations are working, essentially. But the other thing to point out is the norms for the initial external extensor moment are quite a bit higher than what you see here. This is usually to indicate the person doesn't trust that knee because they're not loading it in a situation where then they can eccentrically control the acceptance of their body mass. So they don't quite trust it yet. So it's a much lower value. All right, so I know there's a lot more we could discuss about this paper, but we'll jump to very quickly the would you accept it questions. So is it good enough to accept as it is? Is it yes from over here? So you learned from my critique about don't be too critical, right? Is there any no's? Anybody want to see something else from this before it gets accepted? Anything you want to ask the authors for before you say, yeah, go ahead? No? It's almost tea time, so might as well accept it, right? That makes sense. That's a legitimate thing. Actually, reviewers and editors get fatigued. And after a while, they'll say, oh, I've seen this thing 3 times. It keeps improving. It's not quite perfect yet, but I'm tired of looking at it, so let's accept it. And so if you're the writer, that's what you hope for. Is that after a while, they keep saying a little more, a little more, a little more, and finally they get full. And then they just accept it. And then you can move on to the next thing. The worst is if you submit it and they reject it immediately. It's not necessarily the worst. It just means you can't publish in that journal because they won't like it if you revise it and resubmit it either, unless you totally redo the study. But if you get an initial review and haven't flat out rejected it, my policy is you can always publish it in that spot because you just please the reviewer until they say yes. And you can always rectify the questions until they say yes. There has been a couple times where they say, we don't like this at all, but if you want to resubmit it, fine, I guess, go ahead. And then we look at the critiques and say, there's absolutely no way we can please this reviewer. Let's go somewhere else. So the trick is just to find the home. You just want to find the right home for your work, because sometimes the place you think is going to be the best spot because it's a prestigious journal, it's just frankly really hard to get there. You have maybe 30% acceptance rates for those journals. And it's great to get there, but it's also good just to have it published and out. So maybe second tier journal is also okay sometimes. All right, okay, that's all I have. Hopefully it was meaningful and helpful to discuss the three types of articles. I think you will agree they're probably very different from each other, but there's some similarities as well. And they have some strengths and weaknesses that you can figure out how to tease out and how to critique. So hopefully it was good. Thanks. Anytime. Is that right, Perry? I think so.
I think you go for a short break. Break service on leaving 2 o'clock. And yes, better the last 1 week, how you are feeling. That's what I need after your tea break. I think the lecture about how the audience feeling. Okay. Right? If you leave 2 o'clock, if I schedule it validity function, there is a school feedback session, but it will not be available. So I need to know what is the file. We'll go for short break and come back.
Okay. Yeah. No, it's good. I didn't realize that was part of it. It's like, oh, okay.
If you are done with your
No, it's okay. It's to come to provide it.
yeah.
We do that. It's usually very quick, just paper edit. So we don't know actually what they think, we just know what they write.
Verbal business and writing. Both.
Yeah.
Okay.
Yeah.
No, no.
Of course. Yeah. Good. Weird. Interesting. It's like our natural environment. Yeah. Yeah.
Connected with the train.
Yeah.
I had a discussion that just about the first where I did the first time. I was like, this is like so good. Yeah, I found it like very opinion. But the points that you mentioned when discussing, like the conflicts of interest, then I was thinking of it, and then I again went through. And I got a feeling in this side, as if I was feeling more. I felt like was it just fooled by night kind of thing. Because like if you think about it, then it seems as if they just want some valid study where they want to like on the basis of which they can promote their product, right? And nothing else. That is what I got it. Like,
That was your first time to it.
absolutely.
That's a very common question. It's like read one article once,
Yeah.
then you can get like a first one. You get two out of bad. You have to go and say, I don't know. And then secondary, it's actually pretty good. You know, questions. But again, most cases, it's still good work. But sometimes you get a little bit bad.
Yeah, that's one.
Especially if you don't the surroundings.
Yeah.
So we try not to get too cynical, but sometimes you think
It could have been better. Not like that.
it's really rare for them to like employees on I was surprised. Usually just it's just but it's two types of employees. Then it's really
Like 100 by 99, it's a mixed with a little bit bias, would make slightly inclined. I mean, definitely they would want positive results. Like if they are having hypothesis statement, definitely they are having positive results. If it is 100 by 99.
and I think we've done work for them before in my lab. And it's always like fixed price contract. But this project is they'll give you a report. And but we never publish those sort of projects because I don't want people to like presenting science that's
Biased.
so that's fair. I treat it as third party monitoring. So then I just give them a very unbiased report.
Yeah.
They have a contract with them, pay me, whether I say yes or no, right? And so a couple times they have a number in mind that they want to have. And they'll tell me ahead of time, this is what we think is going to be the test. So one time the value, let's say, was like 1, right? And so I reported back that it was 0.92. And they said, are you sure? Can you double check? Because we think it's actually 1. So I rewritten the numbers with it and analyzed it slightly away. I said, this model here would reveal like 9.2, or sorry, 0.93. And they said, well, in house we got closer to like 0.98, which we're happy to say
Round it up to what?
Yeah, I said, well, if you put it around, then it's actually 0.9. So I sent them the report, and they were happy with that, but so I mean, that happens all the time.
Yeah,
Company
but
wants to know it.
that is for sure that they would come to you afterwards.
But
With
they have come back.
Wow.
Yeah, I know.
Yeah, that's it. That they want the unbiased opinion.
Yeah. They still don't like the knowledge, but they come yeah.